Using standard 3-phase 120/208 volt circuit breakers, whether bolt-in or snap-in a 400 Hz application is not recommended and can pose a safety hazard. Circuit breakers are designed and tested for specific frequencies, and using them at higher frequencies can result in excessive heating and premature failure. The magnetic trip characteristics of standard circuit breakers are designed for 50/60 Hz frequencies. Using them at 400 Hz can alter the trip time, potentially leading to dangerous conditions. Circuit breakers rely on magnetic and thermal mechanisms to interrupt fault currents. At 400 Hz, these mechanisms may not operate as intended, increasing the risk of electrical fires and equipment damage. Using bolt-in circuit breakers in 400 Hz applications has been done in the past, but it is not a recommended practice. Bolt-in circuit breakers are not underwriters' laboratories, or all listed for 400 Hz applications, which means they have not been tested and certified for safe operation at that frequency. Bolt-in circuit breakers offer better heat dissipation than snap-in breakers, but this is still not sufficient to prevent overheating at 400 Hz. Bolt-in circuit breakers can create more arcing during operation, which can pose a fire hazard in 400 Hz applications. For 400 Hz applications, use circuit breakers specifically designed and approved for that frequency. These breakers are typically marked with a 400 Hz rating. It is important to understand the risks associated with using standard circuit breakers in 400 Hz applications. It is crucial to emphasize the importance of using circuit breakers specifically designed for that frequency. Provide technical specifications and underwriters' laboratories or UL listings for the 400 Hz circuit breakers being used. Let's delve deeper into why standard circuit breakers are unsuitable for 400 Hz systems, and what alternative solutions are available. Firstly, the fundamental issue lies in the design and testing parameters of standard circuit breakers. These devices are engineered and calibrated to operate within a narrow frequency band, typically 50 to 60 Hz, which is the standard for most residential and commercial power systems worldwide. When subjected to a significantly higher frequency like 400 Hz, the internal components of the circuit breaker experience a range of adverse effects. The most prominent of these is overheating. At higher frequencies, the inductive reactance within the circuit breaker's coils and magnetic components increases. This increased reactance leads to higher impedance, which in turn results in greater power dissipation in the form of heat. This heat can degrade the insulation materials within the breaker, reduce its current carrying capacity, and ultimately lead to premature failure. Secondly, the magnetic trip characteristics of standard circuit breakers are compromised at 400 Hz. Circuit breakers employ a combination of thermal and magnetic mechanisms to detect and interrupt overcurrents and short circuits. The magnetic trip mechanism relies on the inductive reactance of a coil to generate a magnetic field that trips the breaker when a fault current exceeds a predetermined threshold. At 400 Hz, the increased inductive reactance alters the relationship between the current and the magnetic field, causing the breaker to trip at a different current level than intended. This can result in either nuisance tripping, where the breaker trips unnecessarily under normal operating conditions, or, more dangerously, a delayed trip, where the breaker fails to trip quickly enough to prevent damage or injury in the event of a fault. Thirdly, the ability of a standard circuit breaker to interrupt fault current effectively is also jeopardized at 400 Hz. When a circuit breaker interrupts a fault current, it must rapidly extinguish the arc that forms between the contacts as they separate. This arc is a plasma of ionized gas that conducts electricity, and it can sustain the current flow even after the contacts have opened. Circuit breakers employ various techniques to extinguish this arc, such as arc chutes, which are stacks of metal plates that cool and deionize the gas, and vacuum interrupters, which create a vacuum between the contacts to prevent ionization. At 400 Hz, the higher frequency and voltage stress make it more difficult to extinguish the arc, increasing the risk of arc flash and equipment damage. Furthermore, the higher frequency can also cause the arc to reignite more easily after it has been extinguished, further prolonging the interruption time and increasing the potential for damage. The assertion that bolt-in breakers are a suitable alternative because of their superior heat dissipation is also flawed. While it is true that bolt-in breakers typically have better thermal performance than snap-in breakers, this is not sufficient to overcome the fundamental problems associated with using standard breakers at 400 Hz. The amount of heat generated at 400 Hz is simply too great for any standard breaker to dissipate effectively, regardless of its construction. Moreover, bolt-in breakers are not specifically designed or tested for 400 Hz applications, so they lack the necessary features and certifications to ensure safe and reliable operation at that frequency. The increased risk of arcing associated with bolt-in breakers at 400 Hz is another significant concern. Arcing is a phenomenon that occurs when electrical current jumps across a gap between two conductors. It is characterized by a bright flash of light, a loud snapping sound, and the generation of intense heat. Arcing can damage equipment, ignite flammable materials, and cause serious injury to personnel. At 400 Hz, the higher frequency and voltage stress increase the likelihood of arcing, particularly at the breaker's contacts and terminals. The fact that bolt-in breakers are not underwriters' laboratories, or UL, listed for 400 Hz applications underscores the risks associated with using them in such systems. Underwriters' laboratories, or UL, listing is a widely recognized safety certification that indicates a product has been tested and meets specific safety standards. The absence of underwriters' laboratories, or UL, listing for 400 Hz applications means that bolt-in breakers have not been evaluated for the unique hazard associated with a frequency. Therefore, using them in 400 Hz systems is a violation of electrical codes and standards, and it can expose personnel and equipment to unnecessary risks. In light of these considerations, the only safe and reliable solution for 400 Hz applications is to use circuit breakers that are specifically designed and approved for that frequency. These breakers are engineered to withstand the increased heat-altered magnetic trip characteristics and increased risk of arcing associated with 400 Hz systems. They also typically incorporate features such as enhanced arc chutes, high-frequency magnetic cores, and robust insulation materials. Furthermore, 400 Hz circuit breakers are typically subjected to rigorous testing and certification to ensure that they meet the relevant safety standards. This testing includes performance evaluations under a variety of operating conditions such as overload, short circuit, and temperature extremes. The breakers are also subjected to dielectric withstand tests which verify that they can withstand high voltages without breaking down or arcing. When selecting circuit breakers for 400 Hz applications, it is essential to look for products that are clearly marked with a 400 Hz rating. This marking indicates that the breaker has been specifically designed and tested for use at that frequency. It is also important to verify that the breaker has been certified by a recognized testing laboratory such as Underwriters Laboratories, or UL, or Canadian Standards Association, or CSA. This certification provides assurance that the breaker meets the relevant safety standards and that it has been subjected to independent testing and evaluation. In addition to using appropriate circuit breakers, it is also important to ensure that the entire 400 Hz system is designed and installed in accordance with best practices. This includes using properly sized conductors, providing adequate ventilation for equipment, and implementing appropriate grounding and bonding techniques. It is also essential to perform regular maintenance and testing of the system to identify and address any potential problems before they can lead to equipment failure or safety hazards. In summary, the use of standard circuit breakers in 400 Hz applications is a dangerous and unacceptable practice. The potential for overheating, altered magnetic trip characteristics, and failure to interrupt fault current poses a significant risk to personnel and equipment. The only safe and reliable solution is to use circuit breakers that are specifically designed and approved for 400 Hz applications, and to ensure that the entire system is designed and installed in accordance with best practices. Explain to the customer the specific risks associated with using standard circuit breakers in 400 Hz applications. This explanation should be clear, concise, and easy to understand, avoiding technical jargon where possible. Provide specific examples of the potential consequences of using inappropriate circuit breakers, such as equipment damage, fire hazards, and personal injury. Emphasize the importance of using circuit breakers that are specifically designed and approved for 400 Hz applications. Explain that these breakers have been engineered to withstand the unique stresses associated with high-frequency systems and that they have been subjected to rigorous testing to ensure their safety and reliability. Provide technical specifications and underwriters' laboratories or all listings for the 400 Hz circuit breakers being used. This information will provide the customer with confidence that the breakers are appropriate for the application and that they meet the relevant safety standards. Be prepared to answer any questions the customer may have about the 400 Hz system and the circuit breakers being used. This will demonstrate your expertise and commitment to safety. Remember that safety should always be the top priority when working with electrical systems. By taking the necessary precautions and using appropriate equipment, it is possible to ensure the safe and reliable operation of 400 Hz systems. When addressing concerns about using standard circuit breakers in 400 Hz applications, it is crucial to offer concrete and actionable recommendations. Firstly, provide a detailed explanation of the specific dangers associated with using standard 50/60 Hz circuit breakers in a 400 Hz environment. This should include a breakdown of how the increased frequency affects the breaker's performance, leading to overheating, altered tripping characteristics, and potential failure to interrupt fault currents effectively. Secondly, present a clear alternative solution by recommending the use of circuit breakers specifically designed and rated for 400 Hz applications. Emphasize that these breakers are engineered to handle the unique demands of high-frequency systems, ensuring safer and more reliable operation. Thirdly, offer technical specifications and underwriters' laboratories, or all listings for the recommended 400 Hz circuit breakers. This provides tangible evidence of the breaker's suitability and compliance with safety standards, giving the customer confidence in the proposed solution. Fourthly, provide a cost-benefit analysis that highlights the long-term advantages of investing in the correct 400 Hz circuit breakers. This should include factors such as reduced risk of equipment damage, decreased downtime, and improved safety for personnel, ultimately demonstrating that the initial investment is worthwhile. Fifthly, offer to provide a consultation to review the customer's specific 400 Hz system and assess their circuit breaker needs. This personalized approach shows your commitment to providing the best possible solution and helps to build trust with the customer. In addition to these recommendations, it is also important to address any misconceptions or concerns that the customer may have about using 400 Hz circuit breakers. This may involve explaining the differences in construction and operation between standard and 400 Hz breakers, as well as addressing any concerns about the availability or cost of 400 Hz breakers. By providing clear, accurate, and comprehensive information, you can help the customer make an informed decision and ensure the safe and reliable operation of their 400 Hz system. It is vital to reiterate that compromising on safety in electrical systems is never worth the risk. The potential consequences of using inappropriate circuit breakers can be severe, including equipment damage, fire hazards, and even loss of life. By investing in the correct 400 Hz circuit breakers, you are not only protecting your equipment and personnel, but also ensuring the long-term viability and success of your business.